Hello everyone, welcome to today's database class. Today we are going to talk about database normalization. This is a brief outline of my today's talk. So I'm going to highlight what is normalization, why is it necessary, and different database anomalies that may occur if there is no normalization. I'm also going to highlight the normal forms. So the first normal form termed as 1NF, the second normal form termed as 2NF, and the third normal form termed as 3NF. So we start with what is normalization. Normalization is a technique of arranging the data we have in multiple related tables. So what it does, it minimizes data redundancy. Some of you might wonder, what is data redundancy? Now, data redundancy is duplicating the same data multiple times, and sometimes we do it unnecessarily. For example, if we look at the database maintained by a video rental shop, this is the database that they currently maintain, and let's say they are storing the customer name, salutation of the customer, their address, phone number, movies that they have rented, and the category of those movies. For example, a customer, Alice Smith, she is currently renting Pirates of the Caribbean, Terminator, and Mission Impossible. And the category column shows the category of those relevant movies. Now, if you closely look at the columns, you will see that some of the information are unnecessarily duplicated. For example, the Pirates of the Caribbean movie is an action type movie, and since it is a popular movie, 3 customers has rented it out, and then it is recorded 3 times. The same goes for the Terminator as well as the Hangover, which are recorded multiple times unnecessarily. Now, what data redundancy does, the duplication consumes unnecessary space. So we are only seeing an example of 4 customers, but consider that a video rental shop may have hundreds of customers, and maybe a particular popular movie, it may be rented out, say 20 by 20 of them. So in that case, we are storing unnecessary data. So it can also cause some other issue which are called database anomalies. Now I'm going to go through these database anomalies and look at each of them. The first one I'm going to talk about is called insertion anomaly. So let's look at the database again of the video rental shop, and as you can see that currently if a new movie comes up, say the Troy movie, it has come out and we would like to insert that information, but we cannot insert that information unless and otherwise some customer is renting it out. So that is the insertion anomaly, that we cannot insert data in the table unless some unrelated thing occurs. Now we'll look at update anomaly. So consider that in the same table we made a mistake, and the Pirates of the Caribbean movie, it is termed as romantic movie, but actually it is an action movie. Now if we would like to update this information, we would have to manually go through each of the records where Pirates of the Caribbean is rented out by someone and make it as action movie. But what happens if by mistake we forget to update one of the records, then the database becomes inconsistent. For example, in here, Pirates of the Caribbean is shown as an action movie in 2 places, and in another place it is shown as a romantic movie. So that's how update anomaly can occur in a database. Now we'll look at delete anomaly. Now consider that the Notebook, it's a romantic movie and it has only been rented out by Bob Robinson. Now if he returns this movie, then we need to delete this information that Bob Robinson does not have Notebook movie anymore. If we want to do that, what will happen? We will lose this information completely. We would not remember what kind of movie Notebook is, and our database become like this, where we do not have any information regarding the movie Notebook. So as you can understand from this, that the data duplication, it consumes unnecessary space and it also can cause database anomalies. So how we can solve this? We can solve this through normalization. And in normalization, there are different normal forms, which are first normal form, second normal form, third normal form, as I mentioned earlier. Now we'll see how this normal form works. So we start with the first normal form. In the first normal form, the condition is that each table cell should contain only a single value and each record needs to be unique. So from our previous table, if we convert it to something like this, that all the movie that was rented out by different customer, if we place them in different rows, then each of them are only containing now the movies rented column, it only contains single value. At the same time, each record also become unique. If you see that, in this case, the customer name and the movies rented, both of these columns together make each of these row unique. Now we move on. As you can see that Alice Smith, she has rented out 3 of the movies, and then the combination of Alice Smith and the movie name, it makes a row unique. Now moving on to the second normal form, the condition of second normal form is that the table, all the table that we have, they must be in 1NF. Along with that, there is one more condition, that is there should not be any partial dependency. Now what's a partial dependency? For example, see our previous case where we had all the customer, their salutation, address and phone number, and movies rented and category. Now, as I mentioned earlier, that the combination of customer name and the movies rented, the combination of these 2 columns make a particular row unique. But what about the other columns? What do they depend on? In this case, we can see that the movies category column, it actually depends on the movies rented column. It does not depend on the customer or any other information relevant to the customer. At the same way, the salutation, address and phone number, they actually depend on the customer. They don't have any relationship with the movies rented column. So this is partial dependency, when a particular column depends on a part of the unique keys. Now, how can we remove this? The way we can remove this is dividing them into multiple tables. So for example, for the previous table, we can divide it into 3 tables and we can have a situation like this. Now, our first table, it contains information about all the customer, and we have also assigned an ID with the customer, because some of the customer, they can have the same name. So to differentiate that, we have introduced a new column which is member ID, and now each customer has a member ID. In the same way, we have also introduced another table which is about the movies. So all the movies, they have been associated with an ID. So movie ID 1, it represents Pirates of the Caribbean and the category is action. Now to store the information that which customer is currently renting which movie, we have introduced one more table. In this table, you can see that member ID 1, it is renting customer movie number 1. So that means Alice Smith is currently renting Pirates of the Caribbean. So as you can see that the member IDs, they are coming from this particular table, and the movie ID, they are coming from this particular table. Now moving on to the third normal form. The condition of the third normal form is that all the tables, they must be in 2NF and there should not be any transitive dependency. Now you might wonder, what is transitive dependency? Remember our customer table? It looked like this. Now in this case, the salutation column, it actually depends on the customer name. Whenever the customer is a female, we are using MS, and whenever the customer is a male, we are using a Mr. So the salutation column depends on the customer name. Again, the customer name actually depends on the member ID. So then we have a transitive dependency, that is, the salutation is transitively dependent on the member ID. So to make it into 3NF, we need to remove this transitive dependency. The way we can do it again is again dividing this table into 2 tables. So now we will have for each member a salutation ID, and we create another salutation table where we store the salutation ID as well as the relevant salutation. So this way, after third normal form, our database is normalized and we are able to remove all the database anomalies that occurred earlier. So to conclude, normalization reduces data redundancy and also it minimizes data anomalies, and it is easier to manage data. Thank you, and I'll see you next week.